Every programmer has seen dictionaries, and here you see an example on the screen. But when I teach dictionaries in my beginner's course, there is one question I have a hard time explaining. When should you use a dictionary? In this video, you get the answer to that question. For this example, I create a product list where each product is a tuple of ID, name and price. Here is the list of product tuples. The most obvious application for lists is, of course, the ability to iterate it. And that works. So now I can use the list to print a product list on the screen. But I want more. Customers in the shop should be able to scan barcodes and see the product name and price. How does that work with my product list? I will search for this ID. In the loop, I check for the ID. This will work when I execute the code. I found the product. I can even optimize the code when I break the loop when the product was found. But even with the break in place, there is a problem with this approach. When the search product ID is at the end of the list, the whole list needs to be iterated. Let's see when this is starting to become a problem. First, I measure how long the lookup takes. I measure the time before the lookup and after the lookup. The output shows the lookup time in seconds. For small lists like this, it is not noticeable for humans. But what happens when the list grows? I create the product list in a loop. The list now contains 10 million items. I search for the product in the middle of the list. You might think this will be a problem for Python, but it is really not. Watch what happens when I execute the code. Look at the lookup time, still really small. And yet there was a noticeable delay when executing the code. It turns out creating the list takes a lot longer than iterating it. I can show this by adding this print statement. Notice that when I execute the code, the bottleneck is the creation of the list. So, yes, it took a while to create the list, but the lookup time is still very small. But everything is relative, of course. What if the list of products grows even further? Or instead of one search, you need to search many products. Suddenly the computer needs to do many things times many other things. At some point, the lookup will become a problem. Now, in my code, there are two properties. 1. The list is big, and 2. The product IDs are unique. This is a good situation to use a dictionary. I create a dictionary that has the same 10 million products. Notice that I use product ID X as key, and the value will be a tuple with product name and salary. Now I create the lookup and time how long it takes. How long will that take? Compare the times. It is obvious that the dictionary lookup is much faster. Besides the lookup speed, there is of course another difference between both methods. With the list, I had to make the lookup code myself by iterating and comparing the ID. With dictionaries, this was a one-liner. But to be honest, this code can also be simplified, and I'll show how at the end of this video. First, I need to tell you two things about the key in this product dictionary. The key of the product dictionary is an integer, but does not have to be. Typically, you will see numbers and strings as keys, but they can be any data type as long as the data type is immutable. And if you want to know what that means, let me know in the comments. The second thing to think about is the following. The list stored a tuple, including the product ID. The dictionary separated the ID to use as the dictionary key. If you need the product key later, you might have to use it as key and keep it in the tuple. The list variant does not have this problem. If you prefer to use a list over the dictionary, you can even simplify this code by turning it into a generator expression. And to see how that works, click on the screen right now and we'll see each other in the next video. There you learn how generator expressions let you filter lists very efficiently.